In previous lessons, we've gained an introduction to Altair, and in the building blocks of Altair video, we've learned how to use marks and visual encodings to represent individual data records. Now at this point, you would have learned how to use Altair to access Vega's rich visualization system in creating beautiful graphical representations of your data. Today we're going to explore data transformations. These are methods for transforming data, including the use of aggregates to summarize multiple records. And data transformation is an integral part of visualization. Choosing the variables to show and the level of detail is just as important as choosing appropriate visual encodings. So for part 3 of this data visualization in Python series, we're going to specifically look at some of the most useful ones, starting from aggregate transform, bin transform, calculate transform, this one, and filter transform, and finally, I think a TimeUnit transform. If we have time, we probably look into window transform as well, but these are the ones that you most commonly reach out for. These are the most common ones in my personal experience, and these are the ones that you probably benefit from the most. So when it comes to data transformation, just a bit of background here. If you read the documentation, it says that it's often necessary to transform or filter data in the process of visualizing it. In Altair, you can do it one or two ways. It's not just in Altair. Generally, when you're doing visualization, you do it one or two ways. The first one is before you create the chart definition. So before you call up the ggplot, before you do your seaborn, you do your plotly, before you do any of that, you use some standard data transformation library like pandas to wrangle it, to get it into the right shape. Remember, we talked about the tidies data frame. So this is kind of where you try and take data, you remove the, let's say, the NA values, all the missing values, you try and shape them into the right format, and then you call your visualization libraries in. So you do it before the chart definition. That's kind of the method number one. Method number two is do it within the chart definition. This one, not a lot of libraries have very rich support for that. If you try to use something like seaborn, for example, you try and use something like ggplot, plotly, a lot of those things, right, they are really good at creating the chart, provided that your data has already been shaped. But Vega Lite and Altair is kind of a wrapper around that, right? It's kind of using Python API to write Vega Lite's code. And Vega Lite actually provide you a lot of data transformation tools. It also says that in most cases, the better approach is to use the first approach because it is more straightforward to those who are familiar with data manipulation in Python. So if you're very familiar with pandas, you probably want to do, most times you want to keep to this kind of workflow. Because the pandas package offers a lot more flexibility than Vega Lite in available data manipulation. But the second approach also has its use cases. So it becomes useful when the data source is not a data frame, but for example, URL pointer to a JSON or CSV file. So in that case, you don't actually want to create an intermediate data frame and then use the intermediate data frame to shape and maybe memory or stuff like that. You don't want that. You don't want it to be in the memory. You want to actually just take it and on the fly create all this transformation. So it can also be useful in a compound chart where different views of the data set require different transformation. So there's a lot of use case. And also if you just need to do it one-off, you just want a one-off transformation, you want to quickly filter something, well, in that case, you probably don't want to create another data frame, just do a deep copy of that and then change that and filter. You want to just do it within the chart itself because you're not going to use the same data in any of your other application. So those are examples of that. So the most common one I mentioned about aggregate transformations, actually some of this you've seen before. Bin transform, I don't think you've seen it, but you've seen filter transform, you've seen aggregate transform. When you use any kind of like brush, selection interval, selection single, those things you've seen in my first and second video in this series, you see the filter transform being applied as well. And then you will see some TimeUnit transform. This is also something you've seen across the last 2 or 3 videos. So those are things you see as well, but we're going to go into a lot more details. And so this video is just going to be focused on that. So if you're ready, let's open up our Visual Studio Code, our code editor, and let's get started. Okay, so let's start by doing what we usually do. We have to bring in a library. So let's do the import pandas as PD, and we could do import Altair as ALT, and we do our Vega data sets. That's kind of, you've seen this before, right? Vega data sets, and we're gonna bring in some data to work with. So specifically, we're going to be using this data called the movies data set. Some of you may have come across this data. It's pretty popular as the stock data in the data analytics world. So the movies data, let's see how we do that, right? So if I go ahead and just say something like movies URL, and I say take from data, take the movies, take the URL. Let me just show you what it looks like. So let me print that out, movies URL. Bring all of that in. So basically this is just a path to a JSON data, movies.json. You can click on that, you can put that in your browser and take a look at how it looks like. We're not gonna have to worry about that though, because we're just gonna have to say df, or actually instead of df, we're just gonna call it movies, and we're gonna say pd.readJSON. And why is it read JSON? Why is it not read CSV? Well, because we see that this is a .json file, right? So this a CSV, then you could put read_CSV. But here is the JSON, so we want to change that accordingly, and we want to have movies URL. So you can now just confirm that by printing out the shape, for example, and seeing that there's 3,200 rows of data and 16 columns. So all of this is not necessary. Take away the print statement. We don't need that anymore. So we have the movies URL, and in fact, you don't even need this anymore. You could also remove that. That is just kind of, or you could just copy that and paste it down here. Keeping all the import statements into one cell and then dropping this into the second cell. To get us warm up, I think a good idea is to quickly take a look at maybe the head or the tail. Take a look at a few rows of the data so we know what we're working with. All right, so let's go ahead and just print out the head and let's take a look at that. So there's the title. The land goes first love, last rights. I married a strange person. Let's talk about sex. A slam. And then there's the column US grossing. So how much money does it make in the US? How much money does this movie make worldwide? So US gross, worldwide gross. If you see the same amount here, it's because the movie is released in the US only. And then US DVD sales. There's the production budget, and scroll to the right. Production budget and release date, rating. So it's whether it's R-rated or not, whatever rating there is, and running time minutes, and distributor, and source. There is the genre, but there is major genre. I don't know if there's a minor genre. There's creative type, whether this is a contemporary fiction. Director, some of them are none. There are actually some that are not none, but so far in these 5 ones, there's missing values in there. And then Rotten Tomatoes rating and the IMDb rating. So these are the different columns. So today we're gonna learn about all of this data transformation using just this data set. Now I want to make a note here that a lot of times we actually read that into pandas to sort of be able to do all this exploratory, but it turns out that you don't even need that if you don't plan on doing this in your actual production use cases. You may just do something like alt chart, and you could do something that instead of actually passing in the data like movies, so this is a data frame, correct? This is a pandas data frame, but it turns out you could also just pass in the URL. And what Altair would do is it's just gonna go ahead and collect the data from this URL, and then you could do the rest. So let me just show you a few examples. I could say something like mark circle or mark point. Let's just do mark point. Actually, mark circle is fine. And we could just encode, and let's put in the X and Y, right? So what do we want as the X? We could say XX. Let's say we find the IMDb rating. So we could say IMDb, I want to spell that correctly, underscore rating, and you want to have Y. So we could do the Y, and this could be, let's see, we could have I don't know, we could have the production budget. That could be 1. You could just plot that against the Rotten Tomatoes rating. So IMDb and then that's Rotten Tomatoes. Make a note that R and T should be capital and R should also be capital, and then that will be just be a quantitative. So this will also be a quantitative. Now we don't need this quantitative actually, because in pandas, since there are actual columns in the data frame, it's just gonna infer from that, basically looking at the D types. This is something we covered before in the previous lessons in this series. So anytime that any of this column refers to an actual pandas data frame column, you don't actually need that encoding, but let's just keep it there anyway. Let's just run all of that. So let's plot that out, and it will take a while, but you see all of the plots coming up, and you will see, you try to find some correlation probably, right? You see that what are some movies that has a very low IMDb rating but have a very high Rotten Tomatoes rating, or is there some sort of linear relationship? So you see that there is some linear relationship, but it's not very strong, and there are a lot of outliers. And the reason there's a lot of outliers is because we're looking at 3,200 rows of data. So you will expect to see some outliers in that there are movies that are highly rated by IMDb but not as highly rated on Rotten Tomatoes. For example, this is rated about an 8 point something, 8.1, 8.2. There are a few data points here, but then they actually rank pretty low on Rotten Tomatoes. And you have some of the inverse as well. So very low IMDb ratings, they are not highly rated. They are maybe 1.7, 1.8. There are a few of them. And then maybe here, like this one, right? And then you have them on a very high value. So this is like IMDb rating of about 2.7, but then it has a Rotten Tomatoes rating of 92. I would like to say somewhere 91 to 93. So there are a few points like that. Very high Rotten Tomatoes rating, very low, very average IMDb ratings. But then of course there are some movies where everyone agree are great. So Rotten Tomatoes give them a very high rating, close to 100, or exactly 100, and then there are some with very high IMDb as well. What's notable here is that there are not a lot of movies, or maybe no movies, that are above the IMDb rating of 9.5. All right. Now, if you want to change these ratings a little bit, let's say we want to take away the let's say we take away this. We don't want this to be the X. We still want this to be, but let's have this on the X-axis. All right. So on the X-axis, we want to have the Rotten Tomatoes rating. But let's say on a y-axis, we want this to have a, let's see, what do we want? Let's say we want to have the major genre. So there's the major genre. So let's go ahead, create the major, and genre G is capital, so we want to do that. And what should this be? This is obviously categorical, so it can either be ordinal or nominal. Now, ordinal means that they are ordered, they are rank ordered. There is a rank, there is a high, low, medium, right? They're expensive, cheap, there is a rank to it. But here, what do you think this is? Is there a rank to it? No, not really. There's a drama, there's comedy, but there's no rank to it. So it should be nominal. So let's do that. A lot of this stuff we covered in previous lessons in the series. If these are not familiar to you, if you're not sure why I'm doing an and here, why I'm doing a Q here, then you probably want to go and watch the other videos in this series, in this data visualization in Python series. All right, but anyway, I'm just gonna do this. I don't want this to be a circle anymore, so what I want is to show this as a bar. Okay, so mark bar. Let me go ahead and run all of that. So what's gonna happen is you have a ton of data coming up all the way to the full. And why is that? Well, that's because you're showing every single movies. So there's 3,200 rows of data. All of them is going to be plotted out. This is not what you want. So instead, what you want is you want to actually have some sort of aggregation, right? So instead of doing this, you want to take all of that out, and I want to put a mean to it. Okay, so this is mean. So what you do when you do this is that you're using actually one of two methods to do some sort of aggregation. All right, so remember at the beginning of this video, we talk about the main different transformation. So aggregation is a very big part of that. So there are two ways to aggregate data. This is the first way, and we're going to see the second way, but the first way is to just encode it directly in here. So it's directly put it in the encoding itself. So this is the encoding number one, encoding number two. Within encoding itself, you just put a mean there. All right, and here you could use mean, you could use median, you could use maximum and minimum. And there is also this thing called the average, which is the same as mean, right? So you could also use the average, right? So this is the same. But let's run that and see what happens now. Now it's going to show you just the average. Instead of showing you all of that, instead of showing all the 3,200 data points, it's only going to show you how many data points. That's the number of unique values in the major genre. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's going to compute only 13 different values, one each for each genre. So this is aggregation, and you can do it on the fly with Altair, and that's one very powerful data transformation that you can bring in to your workflow. So I've mentioned that mean is the same as average. If you change that and you substitute that out into average, you get exactly the same thing, right? So here you can answer the first set of questions. You can say, okay, is there a difference, or maybe do different genres of films receive maybe consistently different ratings from different critics? So we're looking at Rotten Tomatoes rating, and I'm wondering, and actually we could turn this off, so let's close that out. So I'm wondering whether or not certain genre tend to perform better on Rotten Tomatoes. And later we can bring in also IMDb and sort of see, maybe are there certain genres that perform really well on Rotten Tomatoes but not necessarily on IMDb, or vice versa. All right, so here we're plotting the average, but you could change that. You could try it with, let's say, the maximum or the minimum, and you see like the minimum ratings. Even at the minimum ratings, you see that the concert and performance, they are still, the minimum is still 40-ish. Documentary, meaning the worst documentary cannot be any worse than the worst horror, for example, or the worst comedy, for example. So comedy and horror, if they go bad, they can really be bad. But documentary, because they probably deal with more objective facts, probably more probably more matter-of-fact style of reporting. So yes, there is a lack of drama, suspense and stuff, but the bad documentary are not as bad as the bad, let's say, the bad horror or the bad thriller or the bad comedy. So using this shorthand method, I want to maybe mention about this. This is using the shorthand method. Let's see another example. Let's see another example of using a shorthand method. All right, so I'm going to go ahead and do the same thing. Remember how I said movies URL, you could pass in a URL, but since we already have movies in here, I don't actually need to read it off the URL, so I could just go ahead and just bring the data frame in there. And I'm gonna use the same mark bar because I want to have something very similar to that same aesthetic, but I want to look at different different encodings. I want to see what if instead of looking at the Rotten Tomatoes rating, I want to look at maybe budget, all right, or let's say production budget. So on the x-axis, this time I want to flip it a little bit. On the x-axis, I want it to have major genre. This is a nominal because it's not ordered. It's not rank ordered. So y, what do I want y to be? I want that to be, let's take a look at, let's say, the maximum, because we used the average earlier. Did I use the average? I used the minimum now, but I showed you the mean earlier. So I'm going to use the max now. and I want to spell production budget correctly, so I want to find that, and it's this column, P capital, B capital, and then in between them there's an underscore. So I want to have max production underscore budget, right? And what do we have this as? We have this as a quantitative. So we want a capital Q here. So this is nominal, this is quantitative. All right. And then what do we want for, maybe let's run this first and let's see what we have. So we have the action adventure. All right, that's cool. Let's actually go ahead and add the numbers so we can hover over them, and I want to show you a few other things later. So we're still using the exact same shorthand method. This one, right? The shorthand method. We actually encode, putting that aggregation directly in encoding. But I could, in the tooltip itself, I could still use the shorthand again. So I could still do the same thing as this. Look, I could do this, and again it's quantitative. So this doesn't exist. The max, this column doesn't exist. So when I try to do something at max, I need to pass in a type here. And I'm saying that, oh, when you do the aggregation, the number, the resulting result of the aggregation would still be a quantitative. So I could do that on the fly, not just for X, not just for Y. I could do it for tooltip. In fact, I could do it for almost every encoding up here. So if I change things around like colors and stuff, I could still use the same thing. I could still use my aggregation. And so this shorthand method is really powerful, and it's kind of, I would imagine that's kind of probably the main way you would do it. And the second way we haven't shown you yet, but the first way you would use sort of aggregation is to do it like that, using the shorthand. All right, so let's see what the deal is. Let's run that, and now we have the tooltip. So this is 100, I don't know, 18 million, 180 million, I don't know, 300 million. So 300 million is definitely this one. So 300 million, this 180 million, this 190 million. So on average, what is the maximum? Let's change this to mean, and let's change this to mean. Okay, let's see. On average, what kind of genre usually has a higher production budget? We see adventure and we see action. No surprise there. All right. If you know anything about movies, if you've been to any kind of cinema theater and you watch any kind of movies, you know that adventure and action, that's where all of the props are there. Explosion, all the CGI, and all kind of like car crashes, buildings on fire, all kind of things. What are the what are the genre that use less production budget? So again, no surprises. Documentary comes to be quite low. I'm actually surprised by comedy. I thought, to me, I would think that comedy, I don't know. The comedy to me sounds like something that you would, if you have the right actors, generally you could go quite okay. But then maybe there's black comedy. I don't know. Maybe I'm confusing them too. And then musical is there, horror is there, thriller is another one that is considerably high. But again, far and away, it's action and adventure. Now, if you sit through the second lesson of the series, you know that a lot of these alt.X, when you print them out to JSON, so for example, if you take this, let's say, if you do this, and you copy that, and you say to JSON, it actually gave you this, right? It says aggregate would mean, fill would be production budget, and then type is quantitative. So it means that you could actually swap this out, and you could write them this way. So let me take this out, and I could do it this way. I could say alt.Y, and I could say fill equals to, and just use the name production. Did I spell that correctly? Budget, right? Okay. And what else do I have? Fill is production budget. What about the aggregation is the mean? So let's do that. Aggregate is the mean. What else? Type is the quantitative. So type is quantitative. Let's do that as well. Is quantitative, right? Now this would give you exactly the same plot. So nothing would change. Let me run that. Nothing will change. All of that will still be the same, right? So you could just specify with all the name key values. You could have the fill, you could have the aggregate, you could have the type, but I don't know why you would prefer that unless you're doing something really, really difficult to produce using the shorthand method. But this is still the first method, okay? So this is the same as this. Let's just put a note here to say this is the equivalent. Let's put a note here, right? Let's put equivalent to this, all right? Now, the second method of doing this kind of aggregation, let's close out this one. The second method of using aggregation, instead of using the shorthand directly in the encoding, so the first method just see us using it directly in the encoding. Now, it turns out we don't have to do them in the encoding. It turns out we could get the same result. Let me show you what I mean. If I could do something like alt chart again, I'll put my movies data frame, and I have my mark bar. So trying to reproduce, trying to recreate what I have up there, and trying to have my encoding. Now, on my x-axis, I still have my major genre, so let's copy that. And my y, same thing, I'm just going to copy both of this. So paste this both in here, and I have my X, that's major genre, that's cool. Y, instead of that, I'm gonna have my new derived column in here. So I don't have that field yet, so I'm gonna leave it blank, and I'm just gonna have my tooltip, and also I'm gonna have it blank right now. Why? Because it turns out instead of actually encoding that directly in here, I could just go ahead and say transform aggregate, and then here I could create the new column. So this column doesn't exist in the data frame, but I could create them. For example, I could create a new column called max budget. So I could say max budget, and this max budget would be what? Now this is very compute that. We said max, and let's spell that correctly. This is production budget, so let's copy all of that, paste this in, and we could say, you could put a Q if you want, but this is in the data frame, so we don't need that. And then you could say, how do you want to group by? So here I want to say group by the genre. So it's either spelled genre or I think it's called major genre. So major genre, so let's do major genre. I want to spell that correctly, make sure that it's all correct. And here we're grouping by major genre, and we're saying that take that and find the maximum production budget in each one of them, and this new field is going to be called max budget. So we could now specify max budget in here. And what is this? Because we now need to put in encoding because it doesn't exist in the original data frame. So what is this actually? This is going to be a quantitative, right? It's just the maximum of production budget for each of this group. So let's put a quantitative here, and we could also just do the same thing up here, paste it in here, and if we run all of that, it still works. So that's the second method. So one is using the explicit aggregation, one is just using the shorthand just directly within the encoding itself. This is directly within encoding, like this one, and this one is basically be more explicit, do a transform aggregate. And this could also have its own use cases. Why would you want to do something more complicated like that? Well, the reason for that is you could then you could chain this, you could have all kind of other things. You could refer to max budget over and over again in all kind of layers, in the different sort of plotting layers, and using them with different encodings and stuff like that, and you only need to sort of refer to this because you created them here, right? So there's also its own use cases. If you want to use this top level aggregate transform, so let me actually put a comment here. This is method number 2. This is top level aggregate transform, more explicit. And the first one is the shorthand method, so this actually up here, right? This is method number 1, and method number 1 basically doesn't try and do a top level, it basically just do it directly, more implicitly. This is within the encoding itself, implicit. And then here we use the shorthand. You could also choose not to use the shorthand by doing this one, just list it all. So there's a lot of ways to accomplish this, and you usually want to pick whatever is the most convenient to you. Okay, let's do another one. Let's do another plot just to make sure all of these ideas are solidified. And this time I want to teach you how to sort this out, right? So let's go ahead, just copy of this, pretty much the same anyway. Just copy that. We are gonna remove the transform aggregate now. So I'm gonna, we don't need a tooltip as well. So for X, what do we want X to be? I wanna now change things up. I've been using the production budget. I wanna use, actually Rotten Tomatoes is fine. So let's actually copy this, right? But instead of minimum, we use the average. So here, I'm gonna copy this, and I'm gonna remove the mean to be min, which is the average. Or if it is confusing, I'm gonna use the average. So I don't have to keep repeating mean, and you won't know which mean I'm referring to, either the MIN or MEAN. So I'm gonna use average to mean mean, but it's the same thing, right? And for Y, now let's say we wanna have the major genre again. So we wanna bring it back. So let's say major genre. And nominal, if we were to run this plot, we're gonna get this. How do we sort this? So that maybe we have the lowest one first, and then the highest one up here. So in terms of average, we want the lowest one to be there, and then the highest one there. So you could sort the value in the data frame directly. You could take the data frame, for example movies, and you can sort them. You can order them, you can sort the values, but you could also do that directly within Altair itself. Now, because this is a group by aggregation, so within the alt.Y, here you could pass in a sort, and then you use another one of Altair's built-in facility, and this is called alt encoding sort field. So encoding sort field, and because it's getting too much, I'm gonna put them into a new line. I'm gonna say encoding sort field and bring it down like that. Okay, and in here you need at least 2 things, but you can have up to 3. So the first one is you want to say use the operation of average, and then perform that on what field. So in this case, I'll say perform that on what field. In this case here, because I'm actually looking at the Rotten Tomatoes rating, I'm just gonna copy that so that I don't misspell it, and I'm gonna say on this field. So here it's gonna say take the Rotten Tomatoes rating field and then find the average for each one of them and then use that as in the sort parameter. So now I would have the sort, and it would then compute the average for each one of them, and then it would pass that into the sort, right? So if this is getting too much, you could also take all of this out. For example, take all of this out, and you could say something like sort criteria or something, and then you could create them, and then you can pass this into sort criteria just like that. You could also do something like this, right? But if this is not a lot, then you could just have everything directly just return it out like that. So average, and then field is Rotten Tomatoes rating. You could have a different field. For example, you could have IMDb rating. You could change that field, and so whatever you specify in that field, whatever you specify in the operation, both of them is gonna use to create the sort field encoding, and then you just have to pass that into the sort parameter in here. All right. So this one allows you to sort by the average, but let's say we want this to be in descending order. So we actually want the largest one, the largest value, the group with the largest value to be high up here, and then slowly go down. So we want it to be descending field. How do we change that? So you change that by passing in the order, and you say order, and you say descending, like this, right? So let's run that. Now you have the descending order. So what do we know about Rotten Tomatoes rating? We know that a lot of the movie critics on Rotten Tomatoes ratings, they tend to favor documentary, and musical seems to be okay, but they tend to favor less of horror movie and romantic comedy. So rom-com, horror, thriller, suspense, and stuff are all right. They are thriller, suspense, comedy, action. They're right up here. They're okay. Black comedy seems to do okay. Maybe cleverer writing, maybe, but horror tends to do not great. The average is only 40-ish. Okay, barely above 40. So speaking of averages and stuff, now averages are a very common way to summarize data, and I told you this is the same thing as the MEN, mean. But if the data set is, let's say the data set contains very large or very small values, we call them outliers, right? They contain very big outlier. The outliers tend to skew the whole statistic. So for example, horror tends to do really well, except there is a massive outlier that causes it to be put down the entire average. So how do you deal with those outliers is one, that's one idea that you could explore. Another approach to that is to, instead of using the average, you could use the median, for example. So instead of average, let's take that out. Let's replace that with median. Do the same thing here. So we set median, and the median is now what is the median actually? Now the median is a point that splits the data evenly, so that half the values are less than a median. So let's say I have a data, and let's say the data looks like that. I have 1, I have 3, I have 39, and then I have 7, and let's say I have 4. All right. So if I take the mean of X, it would just compute the sum of that, right? It would take the 1 plus 3 plus 4 plus 7 plus 39. So I would have to first take the PD, create a series out of X, and then take that and then find a mean. Right, so that would use NumPy to do it. So that would be 1 plus 4, that's 5, plus 3, that's 8, plus 7, that's 15, 15 plus 39, that's 54. 54 divided by 5, that's 10.8. Okay, 54 divided by 5, that's 10.8. But if we were to take the median, so let me take all of this and take the median. So it's going to be 4.0. So you see that even though both are trying to compute averages, this is actually a lot more accurate. Why? Because what median does is that it takes the X, it takes this, and it sort this into a field that looks like this. Okay, so I'm going to put a comment here. It's going to take the field and it's going to sort them into 1, 3, 4, 7, 39. And then what's going to do? It's going to find the median point where half the data are below it and half the value are above it. So it's going to split the data evenly. So here 1 and 3 is below 4, 7 and 39 is above it. So what would be the median? That would be 4. Okay, so that's the kind of the difference between mean and median. So if you have massive outlier like that, this is going to be skewed, right? 1 plus 4, 5 plus 3, 8 plus 7, 15 plus 39, 54. And then 54 divided by 5, that's 10.8. It's going to pull up the entire average. And now you're going to think that, our country has a very high average, let's say, salary income. We're making more money than we used to, or than the neighboring countries. And that's completely skewed. Because if you take out the big outliers, the big billionaires, the one that makes the 1%, top 0.1% net worth individuals, you take that out. And then you measure the income of the population. It's maybe a lot lower than that, for example. All right, so you're going to take away of this just to explain the concept. Now we could change that to median, and you could use median to sort of compute the same plot, but instead of using the mean as the operator, we use the median as the operator. So let's run all of that. surprise, surprise, horror went even lower. Just now we had 40 and now it went even lower. So taking out there are some massive the big movies that are, you know, very popular horror movies, but take away those outliers, they're actually even lower. So horror is actually around 36, I would say. And so when we spoke about mean, we spoke about the median, we spoke about maximum and minimum, the max, mean, median, mean, which is the average. Now all of these are point estimates, right? They are 1 point. There is 1 point statistics. Now we haven't really seen how ratings vary within a genre. So what about the minimum and the maximum? What about things like the 50% or the interquartile range, for example, meaning the median 50%. All right. So let's take a look at how we can visualize that. So I want to talk about this concept called the IQR, the interquartile range. So let's write that out. IQR, that's the interquartile range. Some people spell it this way, some people like to add a hyphen between them, and so like interquartile range. And let's actually go ahead and do the same thing here. We want an alt chart, so Altair chart, but we are gonna remove a lot of those things. We are not gonna have the, okay, let's just remove this one. Let's just comment that out first. We don't have to remove anything. And let's use the interquartile range here. So interquartile range is the middle half of data values within it. So this is the middle 50%, as I like to call it, right? This is the middle 50%. So remember earlier when I gave you the statistics, the 5 different statistics, let's talk about income for a second, right? Now, if you take away the top 25% of income earners and you take away the bottom 25% of income earners, what does the middle 50% look like? Now, that's the interquartile range. That's the that's the middle 50% after you take away the top 25% of top earners and the bottom 25% of earners. Okay, and here we have the Y being the major genre because we still want the major genre to be here on this axis, on the Y axis, but on the X axis, instead of using the median, we don't want that anymore. So what we want is we want to have the middle 50%, so we need a starting point and an end point. We learned how to do that in the earlier sort of course in the series. So that's basically putting the alt.X and alt.X2. So we would have alt.X, we have alt.X2. All right, and now how do we take the first value? Now the first value is just going to be the quarter 1, right? That's the lower quartile, and then the upper quartile, right? So let's go ahead and just say take this, find lower quartile, and then we say Rotten Tomatoes rating. Let's just copy that so we don't misspell any, and we don't have any kind of misspell, typo, and here we just want to encode that as a quantitative. And then we're going to copy pretty much the same thing, and we're going to pass it in here, and we're going to just change that to Q3. Okay, so that's going to take the 25%. This is going to take the 75 percentile. And once you have the 25 percentile, 75 percentile, you can plot the starting and the ending. So let's run all of that. And now you will see, okay, so documentary, they tend to have a lower range. So the documentary tends to do quite well. They usually in the range of 75 to about 90, 94, I would like to say. So it's between this range. Another one, concert performance, also tend to have a pretty short range. Some have a pretty wide range. Musical have a wider range. Comedy have a wider range. Thriller and suspense have a wider range. And horror have a wider range. The poor ones are around 15, I would say 18 maybe. And romantic comedy, same thing, rom-com. And then horror goes up to 64, 63. So you see that there's a bigger range. There's a wider range than the concert performance. If you want to take the median, what do you think the median would be? The median would be Q2, right? So Q1 would be the 25 percentile, Q2 would be the median, Q3 is the 75 percentile. So that sort of concludes our aggregation. You can try and use the mean, the minimum, the median, the maximum, the Q1, the Q3, all of these different statistics. So we're just going to put a save here, and let's take a look at all of this aggregation. Now let's go and talk about a second concept. So to name it more consistently, we say aggregate transforms. Right, creating a new data, create a new data column by aggregating an existing column. Right, want to say that. So aggregate transforms, that's there. Let's tidy up the bottom one as well. Bin transform, this is creating a new data column by binning an existing column. So to explain binning, let's try and get the overcrowded plot that we get right up above. I think we deleted that already. So let's go ahead, just copy this, and I want to just create the same plot. I don't want to have the aggregation anymore because I actually want to have the overcrowding. So we're going to have Rotten Tomatoes, and we are going to change this to IMDb rating. So that's IMDb, believe, and it's spelled with capital R as well. And we're also going to have a quantitative there. And then this is not the bar, this is gonna be the circle, which is basically mark point filled through. This is the same as mark point with the filled through, right? Run all of that. So we have the same thing here. We have the Q, and we have quantitative, and then we have IMDb quantitative. Actually, we don't need the movies. You can just use movies there. So when I said overcrowding, when I said overplotting, it means that data points are just so messy. There's so many of them that they take up just a relatively small amount of space, and now it's just a lot of data to look at, and it becomes difficult to actually discern any kind of pattern, to find any kind of patterns from it. So one way we could think about is how do we group them in some meaningful way, for example, right? So the first way you could summarize those data is to just add a bin equals to true, and Altair provide you this incredible facility for you to just say something like bin equals to true. And what it would do is that it's gonna find some default value. You can change those default value now, but you bin the data frame to a data frame to group all the numeric values into discrete groups. So any value between this range and that range, it bin them into one group. For example, let's run this and then you can see that. So for example, any ratings that are between 30 to 40, just group them into that. Any values between 40 to 50, group them into that. And then now you could sort of see that, okay, there is some sort of trend here where IMDb rating and Rotten Tomatoes rating, again, they don't always agree, but then generally they are, when Rotten Tomatoes rating are pretty high, so say something like 90 to 100, so this one, 90 to 100, generally there are a lot more points in IMDb rating between, let's say, 5 to 9, right, than they are at the bottom half. So you could see some pattern, but not a lot. I said that you could change the number of bins you want to use. The default value is going to be chosen for you. You could exercise more control and sort of decide what kind of how do you want the beans to be used in Altair. So for example, I could say bean and I could say another alt, so which is Altair, and I can say bean parameters, so params like this. And then in here I could say take the maximum beans, that the maximum should be 20. All right, so now you can see it's broken down a little bit more. So instead of having a step of every 10, now you have a step of every 5. So you have 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, all the way to 95, and then all the way to 100. And you see that the movies that are good, for example, movies that have very high Rotten Tomatoes rating, so high that they are in the 95 to 100 bin, that this bucket, the 95 to 100 bucket, generally is less controversial. Most people agree they're pretty good. Even IMDb would rate them pretty well, right? But then the 90 to 95 is where there's a bit more differing opinions there, where in the 90 to 95 you see that there are some movies that are barely rating about 2.5 to 3 on the scale. Some of them are barely 3.5 to 4, but get very high ratings on a Rotten Tomato. You don't always have to use the X number. You can also use Y, and you could use this together with the let's just copy off this so we don't touch that. Right, you could actually use that and combine it with the aggregation concept that you learned before. So in the first part of this this course, we talk about aggregation. Now you can also use this and combine it with some sort of aggregation. If you don't have any good ideas of what to aggregate, maybe you could try to just do a count first, just to see how many of them are there. So let's do a count really quickly, and let's run that. And so now we're just basically doing a count, right? We're doing a count. How many movies that has a Rotten Tomatoes rating between 0 and 5? How many movies have a Rotten Tomatoes rating between 95 to 100? So that's just a simple count here. That's just combining what we learned here with the binning and combining that with the aggregation. And for the aggregation, we're gonna use the count in this plot here. And the mark here, the mark point here doesn't seem to make a lot of sense. I mean, it could still make sense, but probably a better way to represent that is to use a standard histogram. And so instead of actually having mark point, we're going to change that, and we're going to say mark bar, something we learned before. And we say encode. So with this, it's a lot more clear now. We could try and look at the distribution of all the ratings, and now we see that they've been in buckets of 5, right? 0 to 5, 5 to 10. So you could now see what are the, how many movies there. There are fewer movies on this end, but then there are more movies towards this end. But generally, it's quite a uniform looking distribution. Another quick comment on this is that Rotten Tomatoes use, in terms of the ratings, Rotten Tomatoes use a thumbs up, thumbs down judgment. So film critics would generally rate a thumbs up, for example, a tomato. If you've ever seen Rotten Tomatoes, there's either a splash or the tomato, right? So it's either a tomato or it's a splash. A splash is a bad one, tomato is a good one. That's how I read it. I don't know, maybe I got it inverse. My wife just overheard this video and she told me that it's basically fruit fresh and rotten. So it's either fresh tomato or rotten tomatoes. So it seems that that approach is pretty good because you have a very uniform channel, a very uniform distribution. So what I mean by that is that it seems that all the values are quite well represented. What you don't want to see is you don't want to see like where, you know how Uber ratings or Grab or Gojek, for example, you see a lot of the ratings are tend toward the 4 to 5 star. You rarely pick up a Grab that has a 2-star or 1-star or 3-star. You rarely see that. So it's not actually very uniform in that most people are generally favored to give you a 5-star rating. Of even the worst Grab experience, you give a 4-star rating. You know what I mean? You could be kidnapped on the way home and you could still give a 4-star rating. That's really bad, right? A normal ride, you give a 5-star rating. So that's not really a uniform distribution. That is skewed towards the positive side. But here we don't have that problem. We have a pre-uniform one that you have some that has 0 to 5. You have some with a lot of fresh tomato. You have some with mostly bad tomatoes or rotten tomatoes. If you want to compare that with IMDb, you could change that to say IMDb. And now you see a different distribution. Why is that? So IMDb ratings, instead of they look like a different distribution curve, because IMDb itself, they have this is usually called a bell shape, right? Inverted U, a bell shape. And also, apart from just being a bell shape, there is a bit of a skew here. This is called a negative skew, meaning there are more data points towards here, going to the long tail of on the left than to the right. And the reason why IMDb ratings looks like that is because they use averages. They average the score ranging from 1 to 10 provided by all the different sites users. So people would give a rating of 1 or 3.5 or 6.5 or 10. They're not a thumbs up, thumbs down system. They're not a rotten tomato or a fresh tomato. They're not that kind of system. IMDb actually uses a score. So somebody could give a score of like 6.5 or 7.5. And what happened is that people generally tend to give somewhere close to 7 to 7.5. And this is the same for everything. If you go on a dating site, for example, and you ask an average user to rate themselves, right? How do you rate your own appearance? You see that most people tend to rate themselves around 6.5 to 7 or 7.5. Like that is kind of the range where people like to rate things. So I believe there's a name for that kind of biases, but people tend to rate things like 6.5 to 7.5. If you ask them, how much do you enjoy the restaurant, most times you hear an answer that comes to that 6.5, 7, 7.5. If you ask them, how well would you rate your relationship with your in-laws, for example, your mother-in-law, for example, and you see a lot of people who say, it's about 7 out of 10. It's not great, it's not fantastic, but it's not bad either. So it's like 7. That's tend to be a bias. I don't know if there's a name for that. I suspect there is a name for that kind of biases. Let's go back to our topic here and let's do this. So we have the rating, and what if we want to actually let's see, we have the IMDb and we also have the Rotten Tomatoes. Let's take IMDb and let's take Rotten Tomatoes. Let's change the count here and let's put this in here. Let's also apply the same bean. So we have the bean up here. Let's take the bean, we copy the bean and we paste that into this one, right? And let's run both of this. Now we have the mark bar. If we change the mark bar to mark point or mark circle, let's run that. We have this good looking visual. So by actually having the beans, we see that now instead of the points being everywhere all over the place, they are now in increments of 5. And do you still think that there is still a bit of overplotting? You could make the argument that there is still a little bit of overplotting, right? In that there are still some, you can see that there are still some like very crowded field, like this one, you can't really tell whether there has more intensity here or more here. Are there more points here or are there more points here? You can't really, it's not immediately apparent, immediately clear. So points, because they're drawn over each other, so there could be like 25 different data points on here and only 15 on here. But because they look about the same to the naked eye, you can't really tell. So there's still a little bit of overplotting. So how do we find a way to actually tell ourselves where there's more data points on this point and then this one, or there's more data points on this one than this one? You can use a few approaches that you learned in the previous course in the series. You could use, let's say, the color, you could use the size, you could use any of this, right? Now let's take a look at the size. Let's take the size, okay? And the size would just be odd size, and we just want to count. Now it's a lot clearer because not a lot clearer, but it's better than the previous one. So count will tell you just how many, what is the size of each bean. You see that there's a lot of movies in this bean where the IMDb rating is about 7.5 or 7, and then Rotten Tomatoes is about 85, right? So you can use this count. So this is using a different encoding channel. This could be the color, this could be the size, to convey the counts, to convey a different kind of message. And this is kind of making the full use of the plot. Now, if you don't like the size, you could change that to the color. and now you see the color. You could also have the color and the size, but if I use the color, maybe because all of these are the points are a little bit too small. If you use the color itself, it's not quite clear. You can still, the eye can tell better than the earlier one, but still can't perfectly tell whether this is a more higher intensity or this one is higher intensity, because both points are quite tiny on our screen. So what do? Instead of using circle, we could use a bar, for example. There's also the square, but square is also quite small, but the bar is not going to be small, right? Bar is better. So now we see a lot of movies are in this bucket, 7.5 to 8 on IMDb, and then almost 100 on the Rotten Tomatoes. So one good exercise is to compare this with the point that you did above with the size. So one good exercise is to compare this with this, and maybe make an argument about like, what do you think? And here you want to do either field equals to true, or you just say circle so it can be filled in. So you can compare and say, okay, maybe which one is better? Which one is a better representation of the information that you're trying to convey? Which one more precisely compare the magnitude of the individual values? So in which point can you more accurately see the overall density of the distribution of the ratings, right? So in here, you can make an argument that this one probably does a little bit better, easier to look at. But you know, this one, for example, uses the size instead of the color, and that's an exercise that you can do, right? All right, let's copy this one. Let's copy this cell, either capital C. Just click on the cell and then just put a V here. When you put a V, then you want to drag this down to the bottom like that. Now let's talk about time units. All right, time unit transformation. So time units transform. Actually, let's spell them like that. Time unit transform. This is basically group a date by a time unit. Right? So this time unit could be something like the weeks, it could be day, it could be week, it could be month, it could be year, etc. Let's run that. Okay. So let's probably ask another question. What is the best time to release a movie? Right? In terms of critics, what kind of movies, if you release a movie by some people will tell you want to release very close to where the Oscars or the Golden Globe or whatever that is, because that you tend to be remembered better, and then you tend to stand a better chance of being nominated. So let's see if that's true. Let's see if there is any kind of patterns in our across, like, let's say box office returns. Do you make more money by releasing a film close to the end of year? Some people tell you that that's the truth. It's like that. Some people swear by releasing movie closer to the Christmas period because people want to spend family time and they want to go to box office, and so you make more money by releasing movies a certain period of time. Let's see if any of that has any truth to it. All right, using our data set. So let's go ahead, create an org chart again. Okay, we're gonna plot. Let's try this first. We're gonna plot the gross revenue. I want to just maybe have my head here just to see. I don't call it df. I call it movies.head. So it's the 3. Okay, I want to see the US gross revenue. You could also try the worldwide gross revenue. That's also okay. We could use the worldwide gross revenue. All right, and we're gonna put in the movies data frame. So that's that. And you could use the mark area. We've done the mark line. We've done the mark point, but the mark rack, we use the mark bar. So let's try mark area. So let's try mark area. Okay, and we set encode. So we want the x and y axis. What would be the x-axis? The x-axis, and what would be the y-axis? Let's do that. Now the y-axis, we could just use the mean for US gross revenue. So US gross revenue, that would just be US underscore gross. So that's how much money you make in the box office across US, and that's a quantitative. And we know that there's some big outliers as well, so you may want to change the mean to median, all right, to account for those. Just kind of like what I explained earlier about mean and median. You could account for that. But then what you want to do is you want to group them into months. You want to say that, is there a certain month where you should be releasing movies because you make more money on average? But again, all of these are correlation. They are not causation. So you don't want to draw any kind of causal effect. You don't want to say that, oh, because of this, oh, I mistakenly think that the correlation equates causation, and so release it by end of December, you make more money. You don't want to form that kind of conclusion yet. Okay. So these are all just correlations. So what you want to do is you want to say something like month. This will use the date time transformation, date unit transformation. Altair has a very rich complete list of time unit transformation. So I'm gonna open up my browser. I'm gonna show you all of that. But let's put in the release date first. Where's the release date? This one. Release underscore date, R capital, D capital. So let's do release date. And what would this be? This would be a date time unit, a temporal unit. So a temporal unit would be a T. So let's put a column T and let's run that. So this is how it looks like. Now let me show you all the different date transformations, all right? So if you look up the time unit transformation, you can go to Altair, read the documentation. You see that these are all the available time units. And time unit transforms are used to discretize dates and times within Altair. As with the aggregate transforms and bin transform that we discussed already, we've seen the aggregate transform, we've seen the bin transform. They can be defined either as part of the encoding or a top level transform, just exactly the same as what we discussed, aggregate transform. Remember how I said that you could either do it inline, you could do it directly within the encoding itself, or you could just bring it out as a top level transform. The same thing you could do here in time unit transform. In time unit transform, you could use the year, quarter, month, year, month, date, year, month, quarter, month, all of this stuff. You could use any of this stuff. So you could read the documentation. I'm going to put a link to all of this stuff that I just mentioned here. But when we look at this plot, what do we realize? We look at this plot and we realize that the median movie sales in the US, they appear to spike around the summer blockbuster season and the end of the year holiday period. So kind of like when it comes to the November, December period, people tend to watch more movies, or people tend to just crowd together and they have family time together, and people tend to watch more movies. And you realize that towards the end of the year as well, there's a lot of movies that take advantage of that opportunity. You have movies that celebrate, like Home Alone, I think, those kind of movies. So people around the world, maybe not just in the US. And if you're curious about that, just look at worldwide, for example. Let's see if that trend still holds. Let's run worldwide. You see that it still holds for that. You see a similar pattern still shows for the worldwide gross revenue. So it seems like not just people in the US. It tends to at end of year, people tend to be more festive, and you see another one is the summer, during the summertime, when people tend to have more time together. If you don't want to look at month, you could also try and maybe use one of those things that you see earlier. For example, quarter, you could see quarter 1, quarter 2, and then again, quarter 4 is slightly always going to be higher, right? And you could change that to be something like year, quarter, and you can see year, quarter, you can see there's a big spike here. So you could try all of these different date transformation, time unit transformation. In fact, in many of the early examples, even in part 1 and part 2 of this series, you have actually seen me use those things, month, median. If you follow any of my other videos, like build the build an app series, the build an app with PyScript series, you see that a lot of the times I would tend to use one of these date times transformation, and to save myself having to wrangle the data in pandas before I bring it in here. So these are really good stuff to learn and to apply. All right, so copy the cell now, and we're gonna just add another one. And just add here, and again, I tend to just like to bring it up here. Now let's talk about the other kind of transformation. Let's talk about calculate transforms, right? Calculate transforms. So what are they? This is creating a new data column using an arithmetic calculation on an existing column. So suppose you also want to inspect the relationship, but you want to look at, let's say, worldwide growth without considering US, because worldwide growth means US growth is also already considered in it, right? So worldwide growth will obviously include any kind of sales within the US itself. Now, how do we look at worldwide growth minus the US growth? So we want to see, like, how does a movie trend outside of the US itself? We want to see how does a movie how does a movie perform outside of the US itself? So we want to take worldwide growth minus the US growth. How would we do such a thing? So one method is to go back to pandas, create a new column and call it non-US sales. And then non-US sales, you use pandas and use NumPy in conjunction with pandas to sort of take one column minus the other column. And then from there, you have a new column, and then you use the new column and you visualize that by putting that into the encoding, right? But that's kind of defeat the purpose of learning all of this transformation directly in Altair itself. So how do we do that? So one way we could do that is to take advantage of what we learned about earlier. I said that you could either have the transformation directly within the encoding, or you could have them separately by putting it outside, right? And we've seen the example when we bring it outside, we would put something like transform, and you have something like transform filter. The transform filter is something you actually seen before in earlier videos as well. We may use a brush, for example. And apart from transform filter, there's also transform aggregate. So you could also use the transform aggregate to basically calculate some sort of group by, and say group by and then find the mean, group by find the max. But it turns out we could also use another transform called transform calculate, and the format looks a bit like that. So it basically takes the transform and you chain the transform calculate, and then you say perform some sort of encoding, and you could do it in one way, in one order or the other. So this is the same as you could put the transform calculate here, calculate like this, and then you could create a new column that doesn't yet exist. Now earlier you said transform aggregate, and that would be a group by, right? You say group by something and then find the summary value. But here we're saying transform calculate. So now you could do some arithmetic here. I could create a new column that says non-US gross, and non-US gross would just be, let me just say, take the movies data. Now you don't reference movies like that. You don't do it like this. You don't do it like that. Instead, with Altair, what you do is that you say whatever is referred here, this is going to be called datum. So kind of the singular plural form of datum, right? So datum minus datum, and here would just be the US gross. So let's spell that correctly. US gross would be US capital and then gross, right? So what this would do is it will look at the input data, which is movies, and it's gonna find worldwide gross in that column in that data, and it's gonna do the same thing, find US gross in that data, which is the movies data, and then compute that, give it a new field called non-US gross. And now what we could do is we could change this to be worldwide non-US gross. We could say non-US gross, which is referencing this one here. It's still gonna be quantitative though, so we're gonna keep the Q. Let's run that. Now we get that. And now you can see that a movie does, you still see the same trend, the same seasonal trends, but a more pronounced decline in the non-peak months. So months like March and April, that's quite bad. August and September, that's quite bad. Going back to previous notebook, if I search for transform filter, I would find a few examples of when we use it. Like this is one example. We say add selection and then we say transform filter, right? Filter basically allows you to say, oh, if I select this, I want to filter this value. If I select that, I want to filter that value. And this transform filter will just filter everything that is selected in the year slider. Where do we define year slider? Up here. And that's using selection single. If I search for the same thing in the first notebook, pass that in, you see that I would also use the transform filter in the same way. So there's the selection interval, but there is okay, this one we use the add selection instead. But yeah, we would have the transform filter, and now we're gonna see how to use the transform filter as well. But a simplified way of that without creating all the brush again, like what we did in the last one. Let me just copy, let me copy this and bring it down. If we run all of that, okay, we get this. Here you could just basically use a transform filter, and here you just have to specify the filtering condition. So in the earlier one, when you see me use a filter, I filter by this condition that I created, which is the selection. So it should point to this selection single. But here we just say, let's say we just want to say, take all the data. And again, how do we reference this data? We use datum. So we say datum dot, let's say find all of that where the major genre is equal to romantic what? Let's see. There's let's say drama. Let's just find drama. Okay. Drama. And now you're only filtering for all of this condition where the major genre equals to drama. Another one that you see people do is to just do this filtering directly from here, and you say take that data, filter. Another one is to just create a separate data frame called drama, and you would do the subsetting indexing from pandas and then pass that drama data frame in here. But here's another one you could do it like you could do it this way. You could also combine all of this stuff with this stuff. You could combine all of this with taking that, removing all of this condition, and combining that with the date TimeUnit transform. So I could say take all of this, but I want to find where the year of the release date. So there is a release date column in here, right? The release date column. We could take the release date column and only look at the year itself. So extract the year from the release date. How do you spell release date? Capital R, capital D. So we could say take the year, take the datum, and find the release capital R, capital D, and say take any of that is below, that is before the year, let's say year 1995 or 1990. That's the year I was born. So let's do 1990. And now you see that different observations here, but you already applied the first level of transformation, filtering. So this kind of filtering, let's copy this one now again. This kind of filtering here, it's called the filter transform. Do a filter transform. And this kind of filtering that you just see, that's something that you've seen in earlier videos, earlier lessons, even before this one. But here, let's actually create a section for itself. Say this is selecting a subset of data based upon a certain condition, right? And that's what filter transform allows you to do. you could have multiple filtering condition by doing one of these two. So you could say take this. This is first approach is to take this, and then you could take another transform filter. You could have as many as you want. You could say transform filter again, and you could say where the director is not unknown or something, where that's fine. Production budget above 50 million. Yeah. Did I spell that correctly? Above 50, 0, 0, 0, 0, 0, 0. And you could, now you have two different transform filter. Put the datum in there. 20, so we don't see, you see more data points there. All right. This is, mind you, this is 1990, so there's not a lot of movies going around with 50 million to spend on movies or making movies. Okay, this is data points within before 1990, so there are less data points. There are less movies that has that kind of budget to spend about 50 million on making one movie. So that's one way to specify multiple filtering filtering conditions. Well, another option is to have this. Let's take away this one. Let's take away all of the transform filter. We just want this to be one transform filter. And we create two conditions. So let's say the first condition is going to be this, right? So we just copy this and we're going to put that in here. We say datum production budget is greater than that. And then you can use the and to then put in a second condition. So for example, you could say, let's find genre. Let's say all the genre. Let's take a look at all the genre. So movies and major genre. I believe that's the one. Let's say value counts. Okay, so we have drama, we have comedy, we have action, adventure. Let's find all the action movies. All right, action movies. Everybody's favorite movies. So let's take a look at that. We say take datum, and we want to say take the major genre, where that's equal to action movies. All right, or you could say take this or whatever, and find another sort of another genre that you like. All right, and then you could run that. But now it's complaining, it says datum doesn't exist. So the reason for that is you need to then import that again. So this is a second method. It's a little bit more hassle because you need to then say from Altair import datum, and then you could just do datum. Or you could, I think you could try and say something like, you could get away without you doing that import. Let's try and see. alt dot and then alt dot. Then we take away the and. See if all of this still work. Okay, it does. And well, in that case, you don't need to import that separately. Just do it this way. So that's the second method. You could actually have the first condition, then the second condition. The first condition is find all the production budget that is above this. Then you find all the major genre that is equals to action. And you could have as many as you want. Just remember to use the datum that you imported from Altair. And that's kind of it. So zoom out a little bit and see what we've gone through. Okay. So we have spoke about the aggregate transforms. That's creating a new data column by aggregating an existing column. And I show you two ways to do that, right? One is within the encoding implicitly. So that's kind of how you do it, like with this line of code here, minimum, and then you say that's the quantitative view, but you do the aggregation directly within it, within the encoding itself. And then you could also use another more explicit sort of syntax to say that. You could have it being done by saying something like alt.Y field equals to production budget, aggregate equals to this, type equals to that. You can also do that. Then I show you the second method, which is using a top level aggregate transform. This doesn't just work for aggregate, it also works for things like filtering, it also works for things like date time. So transform aggregate, you could use the time unit transformation aggregation, and you could do it this way as well, taking the top level aggregate. And here we're saying that group by major genre, find the max budget, give it a new field called max budget, and then you can use that anywhere in your chart definition, right? So that's the first one. Then we talk about bin transform. We said how the problem for overplotting, how do you combat that? By trying to bin them into sort of discretize them, bin them. And here we bin them by 10, and then here we bin them by 5, and we can visualize them by distributions. And then from there, we move into time unit transformations. And time unit allows you to do something like taking the month of a temporal column and then extracting the month or extracting the year. And we see some examples of that. And then we look at the calculate transform. Calculate transform allows you to do arithmetic using existing columns. So for example, we take the worldwide grossing and the US grossing, we minus them, and then that's the non-US. That's all the movie sales, all the box office sales outside of the US. And we call them a new column. We say non-US gross, and we can take that and use that in our chart definition as well. And then we look at the filter transformation. Now filter transformation, you've seen that before in previous videos, but here we have its own section here, transform filter, and here we pass in one condition. and I show you that you can also combine them with the TimeUnit transform, like this case here. We combine that with the TimeUnit transform, and you can also have multiple transform filters chained together, and this works for everything. This you can transform filter, and then you can have transform filter, and you can chain multiple calculate transform as well. You can chain multiple of them. All right, and another way to do it is to basically have the AND operator or the OR operator, and you get multiple conditions in there as well. So that's kind of it. That marks the end of the third chapter. So what I recommend you do is to open up the Altair data transformation documentation and also give that a read once you've completed this video. And when you're done with that, come back, practice on your own data set, and then in the next video, that will be video number 4. We're going to move into looking at skills, the skills meaning this one, the skills, the axes, the legends, and we're going to look at how do we work with Altair and what are the facilities that it provide to us, for us to work with those things. So that's kind of it for chapter 3. Hope you learned something new. I'll see you again in the next video.